Hey gang, what's up? This video is about the Pantorouter and creating large mortise and tenons with shop-made templates. Let's get going. So I'm getting ready to start the build of a fairly big door, and it's going to need some large tenons. So to start, I needed to figure out what the angle was on the Pantorouter templates. Turns out they're 10 degrees. But first, I should show you this. So the thickness of my tenon is 3/4 of an inch. The width, well, the same math will apply there. So to figure out the template size, we take the tenon size, that's a known size, plus the router bit, that's also known. We'll double that, times 2, and then we'll subtract the bearing. So let's plug in those numbers. In my application, I want a 3/4 thick tenon, plus the 1/2 inch router bit, that equals 1.25 inches, times 2, that's 2.5 inches. We subtract the bearing, and I'm just saying 7/8, it's actually 22 millimeters. So the narrow dimension of my template will end up about 1 5/8. And I say about because it's going to have that 10-degree taper, so I'll cut it at 1 3/4. Now the length of this template, or the width of the tenon, it gets confusing depending on people's perspectives, but the long dimension of this template, that math works the same way. All right, so with the saw set at 10 degrees, I make my cut 1 3/4 wide, and I leave just a little bit of flat right where the 10-degree bevel starts. So plugging in these numbers, I want a 2.5 inch wide tenon. So 2.5 plus 1/2 inch bit equals 3, multiplied times 2, 3 times 2 is 6. 6 inches minus the 22 millimeter or 7/8 bearing. I need about a 5 1/8 inch long template, which is what I have here. I've drawn, cut, and sanded the radiuses, and now I just need to find center. I've shown this many times, but on narrow boards, I love using a scribe. I think this has a 0.5 lead. And so I just guess at half and then make a small adjustment, flipping it back and forth until I'm dead center. And I'm making two templates, one for a 2-inch tenon and one for a 2.5 inch tenon. So that part of the template makes the tenon. Now I need to make accommodations for the mortise, and I start by getting the measurement off of one of the Pantorouter templates. I then took that dimension and put a little mark here just to confirm that would be the end of my groove or channel. And then using that same scribe setup, I can mark the center of the holes in both templates. I then realized this would be easier to just take a 90-degree block, set this against the fence, the bevel's against the fence, and it's perpendicular to the table saw. Boom. There you have it. I then found a Forstner bit that was about the right size to create those round inside ends. And here you can see that slight step that I ended up drilling this later with a Forstner bit to give myself a little bit of slack in that mortise. Now I'll drill a smaller hole for the screw head, and starting with a large diameter hole that allowed me to retain a center. That helps line up the spur on the Forstner bit, right? And this is really a counter bore. And then we'll drill another hole for the screw threads, or the shank of the screw, I should say. I may be going into a little more detail than I need to for these templates, but I get a lot of emails with requests for me to go into more detail on what I'm doing, not just the overall topic of the video. All right, those came out great. Now here I'm just attaching one of the templates to a scrap of material so I can create that long groove. And we're going to do this at the Pantorouter. So we're using the Pantorouter to make a jig for the Pantorouter. All right, here we can lock this dude in place. Line everything up. And you'll notice I've put a center mark on this template, and I'll just line that up with the center of the table. All right, don't need those dudes anymore. We'll slide those out of the way. And I'm just going to use the top of the router bit and locate it into the top of the hole to create that dimension. By bottoming out the router bit in the drilled hole, I can now set the depth stop. Now it's worth mentioning, I could have used this segmented template holder to create these tenons that I was after, but I would have needed a 3/4 router bit, and it would have had to have been very long since these mortises are 3 inches deep. So I used a 1/2 inch bit. Securing those in place, then I can use these stops to create the length of this slot that I need. Groove, I should say. Here I'm flipping it over to cut the other side, but in hindsight, I should have cut some scrap the same width as the template blank. Now I've used the segmented mortise and tenon set, and it is really a fantastic addition to the Pantorouter because with it, with all the different combinations, you can create, I don't remember the exact number, 150 plus different sizes of mortise and tenon. That is phenomenal. But as I mentioned, I didn't have a long enough 3/4 inch router bit. I actually love doing tasks like this. It gives me the option to later know that I can make something like this if I need a special size. And you'll notice I did not drill a center in the template. I thought if I was off a little bit, it would it wouldn't help me. So I thought I can just use a center line and line that up, and that worked. At this point, I remember thinking, yeah, man, this is going to work great, and it did. So with this 22 millimeter follower, I can go on the outside to create the tenon, and then I'll slip in this 10 millimeter follower on the inside to create the mortise. All right, moving on, I've got a scrap of material that's the same thickness as the scrap that I'm going to do the sample test cut in. Yeah. All right, got the scrap sample locked in place. Let's give this a go. The height adjustment on the Pantorouter is a fantastic system. Once you get that dialed in, you can use a scrap of your material and use that in the thickness gauge, and it creates perfectly centered mortises. It's amazing. Everything looks pretty good here, the width and length of the mortise. Yeah, man, love it. All right, let's make a test tenon. This little block I made is just some arbitrary length. I put a magnet on it so I can keep it handy. And with it, I can routinely or consistently bring a piece out the same distance. Sometimes this makes a difference when you're cutting multiple pieces. Of course, you could always use the end of the router bit as per the instructions, but this helps create repeatability. So the test tenon proved to be a little bit fat. So here's the beauty of the Pantorouter is that you can make this slight adjustment. That's the advantage of that tapered template. Yeah. Maybe just a little bit tight still, but I'll make refined adjustments on the actual piece. Oh, hey, incidentally, I wanted to show you how I came up with the center marks on these, just utilizing the other center marks and scribing a couple of, intersecting arcs, and then making a center line off of that. All right, so with the size of the template figured out, the mortise and tenons are the correct size, I decided to start on these grooves in the rails and stiles of this large door. And here's an excerpt from Instagram that I had posted. This will make more sense of the process. So I'm working on this large door. It's a frame and panel, right? Something like that, with a panel cut into some grooves. And to cut the grooves, I first started with a dado set. So a stacked dado set, slightly more than half this distance. And then you just run it through, flip it. That way it ends up dead center. For this application, that's what I was after. However, it was chipping out slightly here. And even though it was a fairly new dado set, I thought it was sharp, but I'd only used it a couple of times. It was chipping out. So I thought, well, I can't have that. So what I decided to do was to make two initial cuts here with a good saw blade. So what I have here is a forest blade, rip blade, and made those initial cuts, and that worked perfectly. They came out really clean. However, it's hard to exactly measure that or check your panel if you have those cuts first. So what I decided to do is go slightly undersized just by measuring with calipers. And then once I had that established, I set up a block in some arbitrary length as a spacer. And I apologize, the block is out of frame, but essentially it was just a block with sandpaper clamped to the fence on the right side of that spacer. To put in there, that's where I made all those cuts. And then I removed this And then I was able to put in a dado stack slightly narrower than this distance and cut that all out. It worked beautiful. And then when I went to check my panel, I knew it was going to be a little bit tight, and it was. So to sneak up on a perfect fit, one of my favorite things to do is to use tape as a spacer, right? So I was able to put this back exactly where it went because I had my block in place, my spacer, put that back. So instead of trying to move the fence to make this distance slightly smaller for that panel to fit, I put everything precisely back where it was, added one layer of tape, made a pass, turned it around, made another pass, boom, perfect fit. Tape as a spacer. Incidentally, this tenon is the same thickness as the panel. So yeah, absolutely perfect. After that, it was a simple matter of creating shoulder cuts. Here at my small table saw, I made a taller fence with a scrap of Formica zinc cut out, and I love this top coat, just makes for easy glide. And the top and bottom rails were wide enough where I didn't need any additional support. They sat flat on the table saw surface, and I was able to make those cheek cuts nice and clean. All right, back to the mortise and tenons, and I set up 2 dial calipers so I could mark the centers of these mortise and tenon locations. All right, first one's cut. Let's see how we did. Man, that is perfect. Just perfectly flush with the groove. I don't know if you can see that, but on both sides. Yeah, man. Beautiful. I was able to set up a fence and actually a stop, again, for accurate repeatability. All right, here you can see a simple layout with this wide rail and a stile coming down. The tenons, the groove, right? And so at the Pantorouter, I'm going to be cutting these mortises, and I just need to know the center of the first one, which is 2 3/4. And then I just simply made a spacer. This is for my 2.5 wide mortise and tenon from this center line to the next one. So spacer blocks, instead of laying out both of these centers, I just need one of them off the bottom, and the mortise and the tenons can be spaced using this spacer block. All right, so here's what I'm talking about. I got the first mortise cut, and I can just simply scoot it over, add that spacer block, boom, lock it down. Everything will be consistent and accurate. So you may have noticed that it's always a good idea to cut your mortises first and then fit the tenons to them. All right, let's see how we did. Okay, come on. There we go. Maybe a little tight still, but yeah, man, that lines up. A little slack of the mortise around the tenon. That would probably go in if I pushed it. I'm just gonna make it just a tad looser to allow for glue, but beautiful, yeah? Oh, hey, wanted to show you this. So when you're cutting multiple tenons and you don't want to run into the one you just cut, right, you can add one of these vertical templates. So it acts as a stop, and yeah, that works well. So this edge, or these edges on these pieces, have been ran through the joiner to get them straight and true, square, all that. And then I actually hit them with a hand plane to get those chatter marks from the joiner out. And then I go back and use sandpaper. What? Blasphemy, right? Well, here's why. I don't use stain often, but this project calls for it, and it's going to get stained dark. And I want all the areas that get stained to be consistent. So if I sand one area and hand plane another, those two surfaces are going to take the stain differently. So here, after I've hand planed, block of wood with some 180 grit, just to even everything out. I'll check that with a low raking light. Boom, looks beautiful. And of course, a quick, easy, and effective way to chamfer all those sharp corners on the tenons. This chamfer on the tenon aids in quick alignment, and also if that was a sharp corner, that would simply squeegee or push the glue once it enters the mortise. Here you can see that tenon slightly shy of bottoming out. Dry assembled at this stage, and I'm feeling good. Now, the rails are going to get thinned down through the planer, so there'll be a little bit of a offset here. Of course, the top needs to be flush, but this is going to get pre-stained and pre-finished before the panel goes in. So these will be separate pieces, stained and finished before glue up. So I need to get this nice and flush so I can just dry clamp it like I have here and hit this with a belt sander. Man, I gotta tell you, I am so excited to glue this thing together. So yeah, lock the doors, turn off the phone, and don't panic. All right, there it is, all glued up, and now you can see why I needed to stain the frame and separately and then assemble it. So the panel with all the marquetry was pre-finished, the frame was pre-finished, then glued and assembled. I ended up using epoxy so I'd have a little bit more open time, and super pleased with the way this turned out. I apologize for the portrait mode, but man, I am so pleased with this. The customer loved it. There's my logo that was created with the Shaper Origin. If you haven't seen my Shaper Origin project to create this inlay or marquetry motif, make sure you check that out. There's my lovely lady Deanne saying, "Look at this." And I sincerely hope you got some good use out of this video. As always, thanks a ton for watching.